All right, so hopefully the activity was really helpful. I really liked it. It's a Desmo thing, not made by me, but somebody else made it. And it's really cool just because you could draw, like in this slide, whatever you want, and the turtle will kind of follow it. So some of you had really cool ones where you had multiple graphs here. A couple of you I laughed because it was all over the place. But yeah, like this one, you're going to have turtles going up. Here I have turtles going down. They almost all of them meet in the middle. I even have one with a curve. So hopefully that was a good exercise, kind of seeing like the relationship between the graph itself and the turtle. So I'm going to spend, I think, this lecture kind of explaining this about, I would say about 60% or 50% explaining kind of the things that you've done. I really did like the exercise, it was really good, but I'm going to review it here to make sure that we all got it. So this is I think the third problem that you guys had. And what I wanted you to look at it was just, if here you have a motion on the left and here you have the motion on the right. I kind of broke it down into it. So technically, let me see if I got my things correctly. Technically, this is what's going to happen. And remember, the whole purpose of this is to kind of explain the relationship between the measurements of the turtle and not. So let's say 0 all the way to 12. 1, 2, 3, 4, 5, 6. All right, so the graph, I kind of just broke it down. I just looked at all the points. And so you have three representations of what's going on. You have the turtle actually moving. You have the measurements right here. And then you have the actual graph. And all these are the same thing. People will digest things differently. I personally can't understand numbers. To me, like this, I can't visualize what's going on. That's why I do a physical graph. So now you have a motion and a graph, and the graph is nice because it tells you can pick out data points from where it is. So hopefully after going through this exercise, you're able to come up with certain things. And these are the takeaways that I wanted you to have with it. So by having this graph, you should have seen a couple things. So I'm going to kind of draw and kind of explain it. So here's the first one, the position. So let's say you had a graph. Here's my x versus time. I apologize, d versus time. And if you have the graph up here, so if the turtle stuff was all up here, I'm just going to do a bunch of weird stuff up there. This means it's always above or away in front of the starting point. So what does that mean? So in case of the turtle, that means it's always, so if this is the starting point, it's always in front. The turtle never goes back into the water. So if you have a graph that's all positive or above the x-axis, the turtle's over here. Now, if you had a graph that's below, and this is one thing I wish the program had. If you had one that's below, so let me draw it here. Whoops, wrong color. If I had one here, and let me do the same color, and now the turtle's down here, that means it went backwards, or it's behind the starting point. Okay, so this one was kind of hard to see because you weren't able to do, but this is something implied that I want us to practice with later. But you were able to play with this. It doesn't matter if it's going forward, backwards, left, right. Some of you even multiplied the turtle. As long as it's above the x-axis, that means it's above the starting point or in front of. No matter what happens, if it's below the x-axis, it's going to be there. Now, could it do both? Yeah, the turtle could technically go in front, go behind the starting point, go back up again. So it could have done that. It could have gone out of the water, back into the water, come out of the water. Other takeaways that I wanted you to get from it was the slope. So I'm going to do it all right here. So you have one here, one here, one here. So D versus T, D versus T, D versus T. All right, so we'll do the positive one first. So most of the stuff that you guys did, at least the first 3 problems that this Desmo activity have, right here you'll notice that's all positive. So the slope here is always going up. So it could be like this. Oops. It could be like this, or like that, or even like that. These are all positive slopes. And what that means, it's moving forward. Okay. You could also have negative slopes. And that means it's moving backwards. Okay. And you'll notice I did a couple things. Oh, one thing I forgot to add here is 0 slope. I apologize. So if it's 0 slope, that means that's not a perfect horizontal. I just realized, let me try to do my other. There we go. A little bit better. That means it's not moving. So positive slope, negative slope, 0 slope. So forward, backwards, not moving. And the last thing I also did was magnitude. Okay, this is how steep. If I can spell steep. Doesn't look right. Steep. Okay, I apologize. Spelling. Haven't spelled in like 6 months, so it doesn't look right. Maybe it's right. But anyway, how steep something is. So here it's steeper. This is the least steep, and this is the steepest. And what does that mean, right? Well, we have to look at the graph itself. So that's our kind of our next slide. So I'll let you guys digest. Maybe you want to pause this, write down the notes. But these are the takeaways from it. Okay. We really think in speed. So when I tell somebody, like you guys were, remember this is a description of motion. So if we go back to the turtle, and I gave you this, and I said, okay, at position or at time 3, 1, 2, 3, you were at 4.2 meters, or in this case, feet. Most of us can't really digest that in our heads. What we really think about is actually speed. So, and in this case, it's actually the slope. Okay, so it's much easier for us to digest. All right, at 0 to 3 seconds, you're traveling 3 miles per hour. At 4 to 6 seconds, you're not moving. And then 6 to 10 seconds, you are traveling 10 miles per hour. For us, most of our brains can kind of comprehend that. It's easier to follow than the exact opposite, which is at time 0, you're at position 0. At time 5, you're at position 5. At time 6, you're still at position 5. And at time 10, you're at position 20. Like in our heads, we know where we're supposed to be, but we don't know how to move in between those places. So we really think in times of slope, or in speed and velocity. So what I said is slope. Well, let's figure out what is slope. Remember, slope is rise over run, right? How much you go up versus down on the graph. In this case, it's change in the rise on this side, which is in feet. I'll be honest, that's another thing I don't like about this one. It should have been in meters or centimeters over change in time. So that's rise over run. So that's technically df minus di over tf minus t1 I. So displacement f minus di over time final minus time f. Now, I'll be honest, this is where someone like Mr. Marchand hates me because I taught him in high school and I like using D. But sometimes when you go to college, they use something called, they don't use D, they use X. So you might see this more often. Okay. So yeah, somebody like Mr. Marchand just hates me because I taught him kind of the wrong symbol and he kind of jokes around it. But you might see it different ways. I was taught D, so it's been embedded in me as well. But you might see X, which is probably the better one to use. So slope. Okay, so let's kind of do it. Let's do this segment right here. So the change or the rise is 2 feet. So 2 feet. Initially, it was at 0. And then the time change was 2 seconds, and it's -0. So here we have a slope of 1 feet per second. And that's a rate. Now, we want a more vector. We also want to include a plus. So plus 1 feet per second is actually the velocity. 1 feet per second is actually the speed. So if we wanted the slope right here, let me do a different color. You have the final one, which is 2 minus 2. And then it is 4 seconds minus 2 seconds. And you get 0 over 2, which is 0 feet per second. Usually when it's 0, you don't have to worry about a sign. And the last part is right here. And here you have final, which is way up here, which is 11 feet. Initial was 2 feet. The time change was 4 seconds to, I'm just going to round it off to 9. 9 seconds minus 4 seconds. And you get 9 feet over 5 seconds. Okay, so that's your right here, and this one's also positive. This one really quickly, you could just see this is 0 feet per second. So we really think of velocity. So it makes more sense here if we say, okay, the turtle initially was moving 1 feet per second, then it wasn't moving at all, and then it was moving almost 2 feet per second. So hopefully that makes more sense because that's how I think. I really do not think in the sense of displacement. I think more of velocity. All right, so how does that help us? Well, now what we could do is do the same kind of graph, but instead of for displacement versus velocity, it could be for, what's it called? All right, so what we're going to do, let me trash all this data. It's the same thing, but now I'm just going to label a little bit better. So from what we previously calculated, this is 1 feet per second. This is 0 feet per second. Hi, Evan. And this one is 9 fifths per second. There we go. And this one is 0. So another graph that we could have is like that. So 1, 0, 9, and then 0. We're going to relabel this. This is going to be velocity, and this will be time. This will be technically feet per second. This is still the same. So I'm just going to break it up so it's easier for me mentally what's going on. Last one is right here. Okay. So for the first segment it is 1. And then the biggest number is 2. So we could do this so that we could do 1 feet per second. And then here's 2 feet per second. And the only thing I ask when you're making a graph is that you don't want to do this. And the reason why you don't want it way down here, and actually I should just get rid of the units because I already have the units up there. You really don't want to do a graph like this. You have a big graph and then most of your data is down here. Well, you have a big graph. Try to take up as much space as possible. Technically, you could do this. 1 and 2 way up here. I don't want you to do also like weird numbers where you're going to have to like divide weird. So if it makes sense, even though it doesn't fill up the whole graph, to do 1 and 2 right here because of these two, that's fine. So you don't have to stretch the 2 way out here. Anyway, so you have that and you just graph it. So the first one was 1, then it was 0, then it was about 2, and it's right around here. So, and then it goes all the way to here, and then it went back down to 0. So this is what the turtle did. In real life, this doesn't happen. You can't, an object can't change velocity at an instant like this. You know, you can't just go from 10 miles per hour to 0. There's a change in velocity. But for now, we're just going to say we're able to, just to make our math a little bit easier. So we could just drop in by kind of just doing I think these are called asymptotic lines, but just have them kind of dotted down like that. But in real life, something happens right here that we're not accounting for. All right, so I apologize for that. This lecture is lasting a little bit longer. But let's do the same thing, but now all the different types of things that you could see. So one thing that you'll actually see is this one. So here, we already know the slope is 0. So if this was 0, then you'll just have a line across here. So pretty straightforward. Okay, what we have here now is, positive. So let's see if I don't have to think. Let's see, green. So the green is the steepest, so it'll be up here. Purple, which is a little bit less steep, so you can have it down here. Oh, I should have extended it. And then you have orange, which is the least. So that's what it represents. Now, for a couple of our assignments, I'm not going to look for exact slope. Just wanted to do a comparative. So this one's higher, this one is in the middle, and this one is the least. But they're all positive slopes, meaning that they're going forward. So when a graph here, when it's forward, it's going to be above the velocity versus time graph. Now here you have a negative slope. So what's going on here? So here you have a negative slope. So that means you're moving backwards. And if you don't trust me, you could do the final minus initial. Final position is 0 feet. Minus initial feet, sorry, I'm about to sneeze, which is 12 feet over the time, which is 12 seconds. So you have -1. So that means you're going below. So in this case, that means you have to extend the graph below the x-axis. Here's 0, +1. Here will be -1 way down here, and you'll draw your graph over here. Okay, so here, when you're below the axis, that means you're going negative. Here we're going to have curves. Curves are a little bit different. We'll eventually get to it, but I just want you to look at it. Think of it the same way, and we'll spend more time with this probably on Monday or Tuesday. Here you have it positive, both situations. Here you have it negative, both situations. And we'll explain it later. So I think it's a lot to keep going since I already hit the 18-minute mark. So we'll end here today. So our homework is going to be practicing this stuff right here, just a relationship between those two graphs. So hopefully that makes sense. Take care, and I'll see you guys next time.